In today's episode, we're going to cover brake plumbing and maintenance, starting first with brake plumbing. All the cars we race came with some kind of factory OEM brake plumbing, and a lot of times your best bet is just to retain the factory system. Some guys will change out the factory rubber soft lines for a Teflon lined steel jacketed brake line to try to improve pedal feel, but for the most part the car is totally functional with the OEM system as it came. OEM routing is actually usually pretty good. These systems were designed to last on cars for thousands and thousands of miles and will generally last in a race application as well. Looking at the hard lines in your car, there are a couple different types of materials used for hard lines. Most OEM applications are going to be steel or some kind of coated steel. Steel brake lines are going to be your cheapest option, the easiest option to find. The issue with steel lines is that they can rust, and in a lot of the cars as we acquire them after a decade or two of use have lines that are rusty enough that they have to be replaced. And you can find steel replacement brake lines for some applications, other ones you have to bend on your own. Another material that's often used in brake lines is stainless, and you see this a lot in hot rods and in some race cars. Stainless lines don't rust. They are a little bit harder to work with because oftentimes the material is stronger, and it can be often hard to flare stainless steel lines, and typically you have to do flaring on stainless steel lines with hydraulic brake flaring tools, not necessarily the tools you can buy at an AutoZone or find for cheap on the internet. Aluminum is not generally used in brake lines, and for applications like ours I would not recommend it. There are issues with fatigue and cracking with aluminum lines that you just don't want to mess with on a hobbyist race car. Another material that has popped up more often now is nickel copper alloys, and these will appear to be like a bronze color. These are generally left more for hot rods. They are easier to route, they're easier to bend and form. The issue with these is they're not very hard, and so they don't have much abrasion resistance, and things rubbing against them will wear through them quickly and you'll develop leaks. When routing your hard lines, you want to look at how the OEM routed the hard lines and potentially reproduce that. Think about possible areas that they could be damaged from abrasion, hitting something on the track, or hitting it while you're servicing and working on the car. OEM brake lines will generally have a guard on the outside to help with abrasion and damage resistance. You can also have issues when you're routing your brake lines of having a local high spot where an air pocket can form, which is difficult to get out during bleeding. It will require more brake fluid volume to be moved from master cylinder to the end of the circuit where your caliper or wheel cylinder is. And in general, you want to make most of your brake line routing form a linear path from master cylinder going down to the wheel cylinder. Another issue to think about is brake heat and the location and routing of your brake lines around objects that are going to get hot, like your exhaust. You don't want to route the brake lines next to the exhaust if you can help it. I've seen some teams run the brake lines through the car or through a frame rail, or relocate OEM brake lines to get them around an exhaust, and this should reduce the propensity for you to get boiling the brake fluid, which could result in a loss of pedal feel or a loss of stopping power. You'll want to shield your brake lines if possible, either with an OEM style outer casing like this, or with some other covering wherever there's a chance for the brake line to contact something or get rubbed. I've often used clear plastic tubing, split and formed over the brake line as a protective barrier. But you want to do this in any area where something can contact the brake line. I actually had a brake line wear through from a brake cooling hose rubbing on it, and despite the fact that the brake cooling hose is plastic and the line is steel, over the course of many races it could actually wear through and develop a leak. When routing your hard lines, you're going to use some fastening method to hold the hard lines to the car and keep them from flopping around and rubbing things. OEM cars come with generally these plastic hold downs, and these actually work pretty good if they're in good condition. If they're not, or you want to go with a better option, these Adele clamps that you can buy are a great option to replace your OEM units, and you can bolt them down or rivet them down in place to hold the brake line. Brake connection types. There are a bunch of different brake connection types that exist in braking systems. Most production cars in America use inverted flare, like this brake line fitting right here. And in inverted flare, you form the flare on the end of the tubing by, in a two-step process, where you bubble out the flare first and then form it again. This creates 2 layers of material in the flare, which is needed to prevent the nut from galling and actually breaking it off. Double flares are by far the most common connection method you're going to see on street cars. Another method is bubble flare, which is very similar to an inverted flare. You just stop the process in the first step and you leave a tulip-shaped bulb in the end of the brake line. This is more common in European cars and some newer American cars. Another flare option that you see on a lot of race cars will be AN fittings. And although this looks similar to an inverted flare, it's not. AN fittings use a single flare where it's only one wall thickness of material. There is a backer that has to go on before you flare to support the flare to prevent the nut from cracking it. And AN flares are 37 degrees versus 45 degrees for an inverted flare. So you need different tooling to make an AN flare. Another option you'll see typically in aftermarket brake fittings is MPT fittings, like you see in plumbing for your household or sometimes in cooling systems. MPT brake fittings are really only meant to go in once, and it's an alternative for aftermarkets to make the parts easier to produce and fit a larger variety of cars. And typically you're going to have a MPT fitting that is an adapter to something else like inverted flare, and you leave this fitting in the brake system after you install it for the first time. Another fitting type that's common is going to be the banjo fitting. And with this type of fitting, you have copper crush washers on either side of a bolt, and the bolt actually clamps the fitting to the brake system and allows the fluid to go through the bolt into whatever element you're bolting this to. It's typically a caliper or a wheel cylinder. These work really well if the crush washers are replaced regularly, so you need to keep an extra set of crush washers, the copper sealing washers. In a pinch, if you don't have them, another method to help them seal better is to take a torch and heat them up and then allow them to cool. This will anneal the copper and make it soft again so that it's easily formed into the rings here on this banjo fitting, which helps it seal better. The last fitting type that you should never see in a brake system is a compression fitting. And this is something, again, you kind of see in hardware store or household plumbing options. These have no place in a race car. They don't hold up to the stresses and high line pressures you see in a brake system. And although a couple parts stores will sell them as a temporary repair kit, don't do it. If you have any questions on brake fitting connections, a great resource is fedhillusa.com. They have information on there about all of these brake fitting types. You can purchase parts there or just get research and knowledge on how to plumb your car. If you decide to run your own brake lines, how do you go about making your own brake flares if you're using inverted flare, AN flare, or bubble flare? You can purchase one of these split style brake flare fitting tools from parts stores. These work reasonably well. The issue with these, if you get a poor quality one, is misalignment of the two halves of the block can lead to an uneven flare or a flare that's tilted relative to the center line of the tube and the fitting. That will make it hard to seal and potentially lead to leaks. Eastwood sells a fairly cheap flaring tool which has two halves of a block that are clamped in a vise, and then you flare onto that block. Those provide a little bit smoother, more even flare that is parallel to the axis of the tube, and I've had great success with those. Higher up from there, you can get a hydraulic flare tool, which is required for stainless steel tubing. Those provide a great finish and speed up the process a lot, but they have a fairly high price, like $150 to $250 for an entry-level model. All these are great options. Again, you need to make sure that you get the correct flare for the system you intend on flaring. Not all tools that do inverted flare will do bubble flare, and like we talked about before, if you're going SAE versus inverted flare, you need to get the right angle tool for the job you're doing. In case you need to do a brake repair while you're at the track or in service, I would recommend always carrying with you some brake hardline and a flare tool that will handle all the flares that you happen to run in your race car. It's another reason why I typically stick to just inverted flare and put no AN fittings or bubble flares into my systems, because I can repair it with one tool. An Eastwood tool or one of these split tools thrown in your toolbox can be a great option to get you through the weekend, and typically these small tools will allow you to fix it on the car rather than requiring you to remove the entire brake line and put it in a larger hydraulic flaring device. If you don't feel confident in your ability to create quality flares, another option is to buy pre-flared tubing from your local parts store in a length approximately the length that you need for your part. You can buy these in several different lengths and throw them in the trailer because they're relatively cheap. And in a pinch, you could plumb both ends and leave a loop in it, or route it in some path that allows an extra long piece to fit in your car, finish the weekend, and then have a proper line bent for you, or purchase a proper OEM line from an aftermarket source. Soft lines. Your system will need soft lines out at the wheels or any other location where the lines pass through some suspension component that has to move. You don't want any hard lines moving on the car dynamically while you're on track. You want all of that movement handled between two ends of a soft line. Soft lines typically are either the OEM style that are rubber, or a Teflon lined stainless steel braided hose like this one here. OEM lines have the advantage of being readily available. They're typically cheaper, and you can get them at parts stores if you happen to forget to pack one in your gear and you need one. There's a disadvantage to these lines that they have a little bit more compliance, so you'll feel the pedal be a little bit squishier compared to a steel braided line. And typically they come with banjo fitting ends, and if you're running an aftermarket caliper, you may have an issue where you need an adapter, or they simply won't work with your style of connection. With steel braided line, the ratio you run into is that they have shorter lifespans. They typically age out about every 5 to 6 years, and they require replacement. Another concern is that you have to be pretty good at assembling them, and typically in a race car application, they're tested before they go on track. If you're doing the field service yourself and you have to replace the soft line, you need to really make sure you do a good job and understand how to assemble these soft lines and how to use the fittings that come with them. They're also a little bit more expensive to replace than an OEM line, and for most of the cars that I race, I just stick with the cheaper OEM solutions and carry tons of spares. You'll want to change out these soft lines that are OEM style about every year or two. Even though they'll last longer than that, typically they end up with small cuts or marks in them, and you want to replace them whenever you notice a cut in the outside surface or in the jacket here of this soft line. Another thing to look out for with these soft lines, you do not want to hang something like a caliper from the soft line. Soft lines are not designed to be tethers or chains or cables, and pulling them like this can actually cause them to fail or fatigue them early. Another thing to think about when you're selecting soft lines, OEM soft lines come with these brackets that have been designed from the factory to make sure your soft line doesn't contact your wheel, your suspension, or anything else. If you're running your own soft lines, aftermarket stainless steel Teflon lined lines, you need to make sure you either retain these brackets or make some brackets of your own to keep your brake lines off your wheels and your suspension components. We mentioned it earlier, but you really need to make sure you replace your soft lines on some kind of regular interval. The OEM soft lines, people do a pretty good job of recognizing that these have gotten old, and you can visually inspect them and see cuts and look at the condition of the rubber. The stainless steel jacketed lines, though, it's hard to see the defects, and because of that, you need to replace these in a regular interval. These are not a lifetime item, and at best, you're going to get 5 or 6 years out of it. In reality, in our racing, you need to think about how often it's flexed in the ends, look for kinks in the ends, look for breakdowns in the jacketing on the outside, and if your stainless steel line has a plastic outer covering, which is meant to prevent dirt from getting in between the jacketing and the inner liner, look for cuts through that, and in general, you're going to end up about the same interval of every year or two replacement, regardless of which hose option you go with. Brake fluid is one of the items you have to maintain in your car and change out on a regular basis. And the reason why is because brake fluid absorbs water. Different kinds of brake fluid absorb water in different degrees. For example, in the hot rod world, some cars have silicone-based brake fluids which don't absorb hardly any water at all. You don't really see these in race cars, and silicone brake fluid is incompatible with traditional brake fluid, and mixing the two together makes a mess. Using traditional brake fluids, you will see an advertised wet and dry boiling point for most of your aftermarket or high-performance brake fluids. The wet boiling point is the temperature at which the brake fluid will boil when it's used and has absorbed all the water that it possibly can. The dry boiling point is the performance of the brake fluid when it's brand new. As the brake fluid ages, you get performance that exists somewhere between these two numbers, and the spread in these two numbers gives you an idea of how good the brake fluid is going to be in your car. Really high-end brake fluids like Castrol SRF, the spread in those two boiling points is really low, and the wet boiling point is higher than a lot of brake fluids have as a dry boiling point. So buying quality fluid can extend the intervals that you change your brake fluid on, and can actually pay off in the long run if you can absorb the upfront cost. Another reason to change out your brake fluid regularly is corrosion. Brake fluids that don't absorb enough water to change their wet boiling point could still potentially have water trapped in the system, and it's possible for your brake system to corrode from the inside out. This is a concern when cars sit for a long period of time, and if your race car has been down and out for a year or two because you're fixing something else, it's probably a good idea to change your brake fluid regardless of how good it is or what quality brake fluid you used. When you're changing out the brake fluid in your brake system, also keep in mind your clutch system, if hydraulic, will have brake fluid in it as well. For the same reasons you change out brake fluid in your brakes, you want to change out the fluid in your clutch system and use a quality fluid because, just like your brakes, you can potentially boil your clutch fluid if it's near exhaust or something else hot. When it's time to change out your brake fluid, there are a couple different methods you can use to replace your brake fluid and bleed the system. The most basic solution would be to use a turkey baster or some other small pump to get fluid that's in your master cylinder reservoir out, replace it with new fluid, and then with the help of a buddy or a significant other, have somebody press the pedal while another person opens up the brake bleeder, allowing the brake fluid to pass through a small section of hose into a container where you can capture the brake fluid. If you use this method, you're going to want to make sure that you have some brake fluid in your container when you start with, so if you accidentally draw fluid back into the system, you're not drawing air back in, which would make it harder and take longer to bleed. The advantage of this method is that it's cheap and easy. The disadvantage is it takes a long time and requires two people. If you're like most of us and your significant other doesn't want to help with fixing your race car and you don't have many buddies, another option is a power brake bleeder. These make the job a whole lot faster and easier. You typically have to buy an adapter to fit your particular kind of car, but this screws onto the master cylinder reservoir. You pump the system up, pressurize it by pumping the handle here, and then you can leave this attached to the master cylinder, walk to each corner of the car, and simply crack the bleeder open, allow it to drain until you no longer see air or dirty fluid, close the bleeder, and move on to the next corner. For me, this has been a lifesaver at times if you need to bleed brakes during a race weekend or something happens during the race, because it's a lot faster and requires a lot less communication in a really loud, noisy environment when everybody's stressed. If your car has ABS, when you are replacing your brake fluid or bleeding your brake system, you need to think about air that could potentially be stuck in your ABS system. Most ABS systems are going to have a set of valves, one for each circuit, a valve that dumps the brake line pressure and then reapplies brake line pressure, and that's how it controls and stops wheel slip. You can get air stuck in the system between those two valves or in the cavity of those valves, and then the first time the ABS system gets deployed, the air gets released into the brake system and it can reduce your brake pedal feel or make the car potentially not stop well. To release this air on most cars, you're going to need a scan tool or some other factory-approved method to turn on the ABS system, open and close those valves while you're operating either your power brake bleeder or manually bleeding the brakes. For your particular car, look into the service manual and see how they recommend having your brake system bled. And in general, if you have an ABS system, I would try to avoid actually opening up the hard lines that go into the ABS module, because there's a decent chance if you don't expose the system to air, you can simply bleed fluid through it and not worry about having to cycle the system to get the air out. If you don't have access to the tools required to bleed your ABS system correctly, there's no factory manual, or you simply don't know how, another method that could potentially help is bleeding the system to the best of your capability, driving the car in a safe area, hopefully legal area, and pushing the pedal hard enough to get ABS deployment. You then need to bleed the brakes again and repeat this process a handful of times to cycle the air out of the ABS system. Make sure when you're doing this that your driver is aware and you leave plenty of room that you may have reduced braking performance or increased stopping distance while you're doing this maneuver. Brake caliper maintenance. Another thing that often gets overlooked is maintenance of your brake calipers. When you're changing out your brake pads or during a routine inspection, you need to look at your brake calipers for signs of seal overtemp or erosion of the seals from being baked too much. Look for the slide seals being burned, and look for fluid loss. In general, you're going to want to rebuild the calipers every 4 or 5 races on most of the cars we have here, and a rebuild can be just simply replacing the seals that are on the piston and the outside dust seal. For your caliper slides, if you have a sliding caliper like this, every brake pad replacement, you're going to want to check the slides, and probably every 3rd or 4th brake pad replacement, or every 3 or 4 races, you're going to want to pull the slides out, fully clean them, lubricate them with a proper brake grease, which is probably going to be a silicone-based grease, and then reassemble them. Failure to do this can lead to uneven pad wear or reduced braking performance. Signs you need a caliper rebuild. While doing routine maintenance on your brake system or doing a pad change, look over your brake caliper, or if you have drum brakes, your wheel cylinder, for signs that it's been exposed to extreme temperature, like seals being baked out. Look for fluid leaks, which you'll notice as dust or particles collecting on the brake caliper. And look for potential areas where the system has been rubbing or has had abnormal wear from either contact with the wheel or a lack of lubrication on your slides, or in the case of your drum brakes, your shoes. When it comes to these dust seals, the outermost seal in calipers, some teams remove them, some teams don't. The seal can prevent dirt from getting in behind the piston, which will lead to some increased wear on your piston and in your caliper. But on other cars, the seal itself can be an issue where it expands and actually locks up or causes drag on the piston. Depends on each car. I typically don't run them, but if you don't run them, another great alternative would be to run a temp sticker on your brakes and use that temp sticker data to determine how hot your brakes got. You're typically not going to want to see temperatures over about 250 or 300 degrees because it'll cause erosion of your seals. Brake pads and rotors are something that you replace almost constantly in this series, but you should expect to get about 1 to 2 races out of a set of brake pads, especially if you're running a quality brake pad, a pad designed for endurance racing. And rotors you typically will get between 1 and 4 races, again depending upon how hot your brakes are getting and how large your brakes are. You want to replace your brake rotors whenever you notice that they have cracks through the face that go to any kind of depth, and especially that crack has already propagated all the way from the inside to the outside edge of your rotor. If you notice a lot of cracks, you may want to contemplate increasing rotor mass so that you don't have to replace the rotors as often from cracks. If you're testing different brake pads, different brake pad compounds or manufacturers, another thing to consider is that once your brake pads have been bedded in, you want to stick to the same type and compound of brake pad for that rotor. Some brake pad compounds are incompatible with each other and can lead to high spots or uneven pad material distribution on the rotor, which will cause the brakes to pulsate and shake when you apply them. If you're experiencing issues with brake shudder or vibration and you're replacing your rotors more often than every 2 or 3 races, another thing to consider is that it could be your brake compound choice causing the vibration and shaking. This can happen from uneven pad material buildup on the rotor, and typically is not from the rotor actually being warped, but instead from a difference in friction level across the face of the rotor that then excites the rest of the brake system. This can happen from the temperature being either too hot or too cold on the brake pads, and selection of a brake pad that handles that temperature range better can get rid of your pulsation and potentially decrease your costs and decrease the intervals that you're replacing your rotors. If you're not getting 1 to 2 races out of your brake pads and not getting 2 to 4 races out of your brake rotors, contact your brake pad supplier or manufacturer and see what they have to offer as advice. They typically see a lot of race pads come in with issues, and they probably have a pretty good idea of what's wrong, can select a better temperature range pad for you, and can get you into a window of lifespan that works with your budget and allows you to operate at a lower price point. That's it for our section on brake plumbing and maintenance. Make sure you click and subscribe to the channel. Leave any questions or comments you have, and we'll see you next time on Race Tech.